and then as he says, you use that touch sensor. When it gets to your home base, you set it up, you're ready to go, you hit that touch sensor, goes to the next mission. So you saves time. Everything's time. Time's the problem here. The next fun one, which we actually don't use much because of its accuracy, is the ultrasonic sensor. It comes in handy if you got an area that doesn't have a lot of lines or anything, but let's say you have a building on it or something, and you want to know where that building is. You can have it drive along, and when it sees that building, it knows exactly where to turn. The ultrasonic sensor sends an ultrasonic sound out, bounces back, the robot reads that, and converts it into a number that can be used. So I think it's centimeters and inches, I do believe, is your choice.
And be careful on what you're bouncing off. If you're bouncing off kind of a triangular shape, you're not going to get back as good of a signal as something square and hard, right? Because it is sound.
And its sensitivity below like 10 centimeters or 5 centimeters, it's not so good. And above like 40, it's not so good. So, I mean, we have a hard time finding places to use it, but again, judges like it. So we try to incorporate it in our robots somehow for some mission. But it's
probably the most common one I've seen with the ultrasonic is following the wall. So instead of touching the wall, they just want to stay a couple inches away from the wall.
Right.
So instead of following a line, they just kind of measure, well, I'm about an inch away from the wall, I'll keep going, oh, I need to turn to the right more to get back to that inch. But it's,
right. So. Yeah. And again, like we use it here to check our distance from the wall so we knew how much turn to make.
But what about the height of the ultrasonic sensor? Don't you need to make sure that the height of the ultrasonic sensor is also approximately the same height as the object you're measuring?
Yes, and also if it's horizontal or vertical. If it's vertical, it's going to be a little different. If it's horizontal, it'll be pretty easy. You got to make sure you're below it. And as you get farther back, if you're at, let's say you're at the edge, it reads it here, back here, it may not read it. So you want to drop it down enough to make sure it reads it. Because it does, as it gets farther away, it does spread out just a little bit. But and when it's on end, it's a whole different thing. You really got to test it. If you can run it horizontal, it's always best. Of course, it depends on the object. If you have a vertical object and you're just trying to find it,
right,
then vertical will work pretty good. Any other thoughts on that wonderful sensor?
It's probably one of the least used sensors. It really is.
It's cool. It's probably the coolest one.
Yeah, and the thing to go back to is make sure that there's value added, at least from my judging standpoint. Putting a sensor on, you need to have value added on that sensor. Just having an ultrasonic doesn't really, just because you throw it on there doesn't mean it's good. You need to have value for your sensors, not just.
Well, I like to put it on there so the students can see how it works, so they understand the working of it.
And if teams say that, like we just put it on there because we want to see how it works, judges will, okay, that's more acceptable. Some people will be like, well, we have it on there because we're supposed to have it on there. And that's different.
Yeah, actually, like with our FRC team, we used an ultrasonic sensor one year, and because, of course, with the FRC robots being taller, sometimes we were aiming at things that weren't at the same level. You could teach your students the basics of geometry or even trig, like when you have to figure out the distance away when you're looking down at a different angle.
Oh, absolutely.
Like,
absolutely.
it's definitely a way to learn.
Good, because there is a math to it, for sure. So.
The last one, I think, is the famous judge's trick question.
Yeah, rotation sensor. Like I've told all you guys as you come through, don't forget to tell the kids that there's a rotation sensor in that drive.
It's a very common question. I know I ask it all the time. That, you know, how many sensors do you have? And they'll name every other sensor except for the rotational sensor.
Except for that one, yep.
Go.
Yep. Rotations. It counts, obviously, rotations. My preference is the degrees when in doing the programming. You could do inches and meters or centimeters or something like that. There's also timed and degrees. Degrees, there's 360 degrees in a circle. So if you use degrees, you're at the simplest form of math. If you use inches, you have to do some math to get the decimal point equivalent. So, I mean, there's only 360 degrees in that function, that unit. So why go beyond it? Just use degrees. something you can do once you get your robot built is you can actually make a ruler. What you do is you put that on test me and you can get a feedback of what the number is. And you draw a piece of paper, put a mark where the wheel is, and then you push the robot and mark it at 10 increments. And then you can write it down, and then when you do the programming, you can lay this out on your board and say, well, how far do I need to go to get to here? You can lay that ruler down and say, oh, we need to go this many, put it in the computer, and it's there. Otherwise, you got to trial and error, which takes you about 10 times.